So the graphs we've been doing have been like, often you find points, draw a line through them, yes? So kind of the difference now is our graphs are going to just be made up of points. That's what a scatter plot is. It's a graph with a bunch of dots on it. So if we were to take and graph like the amount of time you spent studying for this quiz, don't tell me 0, it'll break my heart, and your score on the quiz, we'd have a dot for each of you, right? Or the x value would be the amount of time you spent preparing, the y value would be the score you get on the quiz. And we wouldn't connect those. So it's a graph of unconnected points. And for these, basically what we're doing is we're looking for a pattern or a relationship. So it helps to determine a pattern or relationship. If we were to look at like the test grades and the studying, the teachers would argue that your grade is going to depend on how much time you study. So study time. So you could do something like that. And in theory, if you study more, your grade should be higher. If you study less, your grade should be lower. So if people have a study time that's low, they're kind of down over here, their grades are probably going to be lower. So you could put like, okay, so the one person studied this much time on the x-axis, they scored this much time on the y-axis. But our graph should just be a bunch of dots. And they won't perfectly be in a straight line. You might have someone who, this person here, studied very little, but did quite well. And you might have somebody that studied a lot that didn't do as well. But overall, we should have the dots kind of going upward. Fair enough? Especially if maybe we didn't call it study time, we just call it preparation time. So if you include like the time you spent listening to me blab on about notes and time you spent doing homework and so on and so forth. Good? So overall for this, we should have a trend that's kind of going upward. Yes? So positive trend. We're going to get to those in a little bit. So correlation. Correlation describes a relationship between two variables. So if you have a positive trend or a positive correlation, that's going to be kind of like our last one. So if you just do kind of some random dots kind of going upward, so that's a positive. Either a trend or a correlation, they call it. And what happens there is you could say, this is kind of my version of trying to write it, if x goes up, y goes up. Or you could look at it, if x goes down, y goes down. So I would say that's probably like that studying thing. Typically, if you study more, you're going to get a better grade. Or like a work and pay. Hopefully, people will find that the ones that work more hours, if their x for number of hours worked is bigger, they should get paid more, something like that. If we were to have a negative correlation, or a negative trend, now when x goes up, y would go down. So x goes up as you're going to the right on your graph, so our y's have to go down as x goes up. So our dots are now going to be kind of going in a downward pattern, something like that. So if you do dots, you could make them in a pretty straight line if you want to, put in a little bit of scatter there. So we'd have those. If you had no correlation, then our dots are going to look like what? Just kind of all over. It'd be like if you had like a shotgun, just go, it's points that are just kind of all over. You just want to kind of make sure that your points aren't overall kind of trending upward or trending downward. They're just kind of this blah on the screen. So this would maybe be like test scores and shoe size. That it's not like if you have bigger feet, your score is going to be higher on the test. Maybe some people with big feet did really terrible, but some did really well. The negative maybe would be something like the amount of money people make with like the trout fishing in Michigan or salmon fishing in Michigan and the number of Asian carp in the lake. That's probably a bad one. But test scores and screen time maybe. If you spend a lot of time watching TV, your test scores would tend to be lower. At least that's what I try to convince my boys. So, okay. What type of correlation would you expect? If you had the number of people living in a house and the size of the house. Positive. If the house gets bigger, number of people living there could be bigger. At least the potential's for bigger. So it'd be positive. And you'll have some people that have ginormous houses and just the husband and wife are there, their kids all moved out. But typically your families with 8 children are going to have bigger houses than your family with 2 children. or no children. Number of mosquito bites and the ounces of bug spray you put on. So number of mosquito bites is dependent. So if you put on more bug spray, X goes up. Number of bites goes down. So that would be negative. Because one variable is going up, the other is going down. So number in college loans, money in college loans and years in college. So this is our independent. So if your years in college goes up, the amount of your loans goes up. So it would be positive. Especially because sometimes you have some money saved up. So your first year you do okay. Last year or so, oh boy, savings are gone. Okay. Number of songs on your iPod and the size of your ears. No correlation. Could look at the volume you listen to things and your level of hearing. Okay, so trend line. A trend line is a straight line through the, I'm going to say middle. I'm going to put middle in quotation marks because is there really a middle of the data. Easiest is to try to take a ruler that you can somewhat see through. So you can take these kind of translucent protractors I have. But if you take that and stick it on your data, otherwise if you have one that you can't see through, you could just kind of do your best guess and then erase and redo it if you need to. But I'm going to go with something like this here. Looks like I'm a little bit low. Maybe I'll try that again. So let me move this over. So you want to be about in the middle of the data. So if I slide this up, something like that maybe. So you have a trend line, something along those lines. And so you can kind of do it like that. If you can't see through your ruler, sometimes something that helps is what I'll do is I'll kind of get down here by this part and be like, okay, so the middle is going to be right about here. And I'll put like a dot kind of there. And then the middle up on this other end, well, this is too low, this is too high, so you kind of want to be right about in the middle. So sometimes I'll do like a couple of dots and I have something to put my straight edge on. That can work if you're using like the edge of your calculator or something you can't see through for your straight edge. But what's nice for this is if we were to look at, well, say it's 101 degrees, what's the ice cream sales? So if you would say, well, this is 100, this is 105, so 101 is right about here, you can know it's going to be, well, kind of between this dot and this dot, but you're not sure exactly where it is. Once you put in this trend line as like your average, it's a lot easier to say, okay, so 101, go up till you hit the trend line, and then follow that straight across. So your sales should be about 85. So the trend line can be helpful for predicting Y for a given X. And I believe that's all I had. Questions?